Today, we're talking about an element that's in every single drop of water, yet it's powerful enough to fuel the sun itself. Of course, I'm talking about hydrogen. And as you're about to see, it's not just element number 1 on the periodic table. It is, without a doubt, the number 1 element in the entire universe. And when I say number 1, I really mean it. Just look at this number, 90%. According to astronomers, that's how much of the universe, by atom count, is made of hydrogen. It's not just another element, it's the raw fuel of the cosmos, the very thing that powers the sun and every star you've ever seen. So that brings up a really interesting question, doesn't it? If the universe is practically overflowing with this stuff, why isn't our world just full of it? Why aren't we swimming through big clouds of hydrogen gas? The answer actually gets to the heart of what makes our planet so unique. Okay, so to figure out where all the hydrogen is hiding here on Earth, we first have to appreciate its role in the grand scheme of things. Let's take a closer look at the undisputed king of the cosmos. See, here on Earth, hydrogen has a totally different personality. Out in space, it's this massive cloud of plasma, but down here, it's a social butterfly. It is so reactive that it's almost never ever found by itself. Instead, it's always bonded to other elements, forming more unique compounds than any other element we know of. And the most famous of all these compounds? Well, you're looking at it every single day. The source material puts it perfectly. Water is the most abundant hydrogen compound on Earth. Every H2O molecule is 2/3 hydrogen, so that's where most of it is hiding in plain sight, in our oceans, our rivers, and our lakes. But not all hydrogen is created equal. It's got a little family of isotopes, which you can see right here. It's easiest to think of them as siblings. First up, you have protium, the original, the one you'll find almost all the time. Add a neutron and you get deuterium, its heavy twin. Add one more and you get tritium, the super rare radioactive cousin. But even though they weigh different amounts, they all have the same electron setup, which means they act almost identically in chemical reactions. So, if all this incredibly useful hydrogen is locked up in things like water, how in the world do we get it out? That's the big challenge, right? Let's look at the ways we figured out how to break hydrogen out of its chemical jail. Turns out, we've got 4 main tricks up our sleeve. For big industrial jobs, we can blast steam over hot carbon. In the lab, it's usually just easier to react a metal with an acid. There are even these special metal hydrides. They're expensive but super convenient for things like inflating life rafts. But the most elegant method, the one we're going to focus on, uses pure electricity to literally split water apart. And this process has a great name, electrolysis. It's simple, really. You just pass a direct electrical current through water, and that energy is enough to break the H2O molecule apart, separating the hydrogen from the oxygen. It is just a beautifully direct way to harvest pure hydrogen. And here's the really cool part. When you do this, you get exactly twice the volume of hydrogen gas as you do oxygen gas. And why is that? Well, think about the formula, H2O. 2 hydrogen atoms for every 1 oxygen. The process literally shows you the chemical recipe of water right before your eyes. It's fantastic. Okay, so we know how to get our hands on pure hydrogen, but what can we actually do with it? It might be the simplest atom in the universe, but as we're about to see, its power is anything but simple. Now, this might actually surprise you. We tend to think of hydrogen for rocket fuel or clean cars, right? But this chart tells the real story. An absolutely staggering 2/3 of all the hydrogen we produce goes to one single task, making ammonia. And why so much ammonia? Because that ammonia is used to create the fertilizer that feeds the entire planet. But yeah, beyond fertilizer, hydrogen is also an element of just raw power. Its reaction with oxygen is what chemists call highly exothermic. It releases a massive amount of energy. We harness that power in oxygen-hydrogen torches that burn at 2,800 degrees Celsius, hot enough to slice right through steel. And that same incredible energy release is what makes it a legendary rocket fuel and gives it so much promise as a clean energy source. Chemically, hydrogen is a real weirdo. It has this incredible dual personality. As you can see here, it just can't decide which team it wants to play for. Sometimes it acts like a metal and just gives away its only electron. But other times it acts like a nonmetal and grabs an electron from somewhere else. This unique flexibility, well, that's the secret to why it can form more compounds than any other element. So we've seen its power. Now let's meet a few of the key members of hydrogen's absolutely massive chemical family, some of the most essential compounds it builds. We already mentioned the star of the show, ammonia, NH3. It's a colorless gas with a very, very sharp smell. The commercial way of making it is called the Haber process. And yep, besides its crucial role in fertilizer, it's also a pretty effective refrigerant. Now, on the complete other end of the spectrum, you have hydrogen sulfide, H2S. This is the gas that gives rotten eggs that unforgettable smell. But this stuff is incredibly deceptive. It's just as toxic as hydrogen cyanide, and even worse, it actually paralyzes your sense of smell. So after a minute, you stop smelling it, even as the danger is getting worse. And then you've got the hydrogen halides. This is when hydrogen teams up with elements like fluorine or chlorine. They form these gases that, when dissolved in water, become really powerful acids. Hydrochloric acid, HCl, is a total workhorse in labs and industry. But hydrofluoric acid, HF, that one's special. It's one of the very few things that can actually eat through glass. So what's the big takeaway here? From the fire of the sun to the water in our own cells, from the food on our plates to the actual smell of decay, hydrogen is woven into the fabric of everything. It's the universe's original building block. The only real question left is, what are we going to unlock with it next?